find the volume generated by revolving the region between y equals x squared and y equals root x about the x-axis. So you've got two functions here. So what we need to do is get a little picture, basically decide which function's on top. Hopefully through the whole place where they generate this region, one function's on top, otherwise it's quite complicated. But let's have a look. So if we just draw our x's, well, y equals x squared, we know is just this sort of simple parabola, just like that. And y equals root, that's a terrible picture, something more, it bounces and goes like that, right? So y equals root x, well, 0, it does something more like that, basically. So this part of the graph isn't really relevant. So if we zoom in on here, they only look like they cross in one place. So when does x squared equal root x? So hopefully you should know that when that happens, when it's 1, x equals 1. So 1 squared equals the square root of 1. So here, x is 1, y is 1, is the point where they cross, 1, 1. So if we do now just try and draw this again so I can actually see what's going on, zoom in a little bit. So you've got kind of something like that, and then you've got something more like that. So this was the x squared, and this was the root x, and this is 1, 1. And they have the same value here at 0, 0 as well. So this is the region, and we're going to revolve this around the x-axis. So the formula's slightly different. So the volume equals pi times the integral between b and a. B and a in this case are going to be the two intersection points of, well, it's going to be y upper squared minus y lower squared dx, just like that. So thankfully you can see that through the whole of this region, the x squared function, it's returning higher y values, so that's our y upper for this whole thing. So we can now substitute some stuff in. It's pi times the integral from 0 to 1. Again, hopefully 0 is going to help us with our calculations. So it's going to be x root x squared, that's our y upper, minus x squared dx. So actually, after all of this, it's going to turn into a very, very friendly interval. So integral even equals pi times the integral from 0 to 1 of, this is just x, minus x to the power 4 dx. Well, equals pi times the integral of x squared over 2 minus x to the 5 over 5, and we need to evaluate that at 1 and 0. So again, 0 is not going to do anything, so that's quite handy. We just need to put the 1 in, so equals pi times, well, it's going to be 1 squared over 2, so that's 1 over 2, minus 1 to the 5 over 5, which is 1 minus 1/5, and that's going to equal pi times 5 over 10 minus 2 over 10, which is, I haven't got room, I'll tell you what, I'm going to go up here. So finally equals 3 pi over 10 units cubed. So with these when you've got two functions and you're revolving the whole thing looking for the region, you just need to hopefully get a sketch, decide which function's on top. You'd be very unlucky if they switch. So if you got, say these met again somewhere else after this, and then you might have a switch between which function's on top, yes, then you're going to have to do this in separate integrals. It's going to take a lot longer. You'd be a bit unfortunate, and I imagine if you do get that, you'll probably get to use technology. And if you use technology, you can use absolute values anyway, so I think you'll be okay. hopefully you get the general idea.